So I'll try to keep this interesting as much as possible. We don't have a lot of time, so let's actually start by me introducing the key topics that I'm interested in, and just trying to categorize them. So I'm looking at technology, I'm looking at people, business, and organization, and trying to see sort of the interactions of all those elements together, particularly through the triggers that technology has brought us. Now, recently I've taken on studies again, and studying neuroscience, and over there I look both on the anatomy of the brain and the inspiration that we can get from it, and also the psychology. Now that's crucial, because despite all the hype of technology, and we've heard that before and we're hearing it all the time, it still really depends on sort of us humans, how we operate in the workplace, the good, the bad, and the ugly. And you would be amazed how much inspiration we can get from how actually the brain operates in order to work better. The previous speaker mentioned Yuval Noah Harari, which I read both his books. I think is fantastic, because there's one thing that he said recently, is that science has solved a lot of problems of humanity for a while, but there are two sort of major categories of problems that science has yet to provide a sufficient answer to, as far as I'm concerned. One of them, I think, is the universe. What lies in the universe, what started it, and so on. The other thing is humanity, or the brain. What is consciousness? What is life? I think science is close, or maybe closer, or at least has an opportunity to resolve maybe the human factor through our understanding of the brain. I guess maybe from that we could get closer into the universe as well. But the one thing that I want to mention over here, in the introduction, they did mention that I transformed Skype into a more of a data-driven organization. That element of data-driven also I don't completely agree with. It's important to use data in decision making, but many times we brush off intuition and gut as something not scientific that you shouldn't actually use. Whereas people like Steve Jobs and others relied heavily on their intuition. And if you think of it, intuition is actually scientific. It is our unconscious mind telling us conscious mind, making those connections that we weren't aware of and providing us that information. So we need to have a balanced view when we make decision making. And instead of calling it data driven, perhaps we should call it sort of informed decision making. Oh, and this is what I want to talk about. So I don't know. Okay, so this is actually the quote from Yuval Noah Harari. For some reason, the presentation is going the other way, but we'll go through that, and those are the two books which I recommend. This is sort of my experience. This is where I brought all my insights to the table. So this is basically my labs. I guess you guys have something similar in your own organization, what either refute or validate some of the hypotheses that you have. And if there's one thing that I've learned is that technology, and we are talking about technology quite a lot, I'm going to talk a bit about it on this presentation as well, can only be actually as good as the people. I've seen that in many organizations working in transforming them, and also advising and helping them turn that around. And the people can also be very as good as the culture. And again, when we're talking about engineers, we are talking about technology, it's easy to forget those abstract elements, but they are as important, if not more important. If there's one insight that I can actually say is that with all the avalanche of technology, we're learning more about ourselves and those soft skills as we are on the technology. And the culture is actually derived from the leadership. So a lot of the change that is required for organization eventually knocks on the door of management and how we work as managers as well. And that's why when you deal with technology, when you deal with data, everything needs to be taken into consideration, and a balance needs to be reached between, I guess, the art and science of how we operate. So I do work in Google, as was mentioned. Now it's part of Alphabet. Started as a research project back in Stanford. Very much a launch and iterate sort of approach, sort of messiness. They embraced messiness in a way as many startups actually do. And this was Google back in the days in '98. Known for innovation, but known also for nurturing sort of innovation. And that's one critical element that a lot of organizations are trying to solve today, is how do you create innovation which is programmatic, not just a one-time hit. And that's not an easy thing to do. So let's again baseline everyone on the disruption that we're seeing in the market from those three layers: technology, people, and business. Technology, I mean, we are in the data conference, just more data out there, more sensors and more data being shared, hence more internet traffic going around. Mobile is the prime device, and behind all these technologies I also see obviously the cloud. Mobile perspective, just recently, big milestone, more traffic from mobile as opposed to desktop. Cloud perspective, the key word over here is abstraction, making it easier, both for consumers on the one hand, and also for IT professionals on the other hand, to deal with technologies, because writing code or developing an app does not end with you on your machine. Sort of other framework and DevOps that it needs to work on. That's where sort of cloud comes in. And if you've got companies that have built a very strong and low latency infrastructure across the world, and you have access to it as a young startup, that's a good first step to take. So those three technologies together, mobile, cloud, primarily I guess compute and storage as well as data, have actually brought back the artificial intelligence from the 50s. It's not a new technology, but right now I guess it was ahead of its time with the compute power, with the amounts of data that we have and storage capabilities. Then obviously there's more uses to it. And I'm sure everybody has a different sort of definition. Basically science of part of the of computer science, machine learning, the key implementation I guess method to it, and the neural networks. Loosely, after the biological neural network is the mathematical algorithms, anything from a simple linear regression analysis all the way to sophisticated deep learning mathematical applications. And going back to the neuroscience, this is, anyone? Come on, wake up. There we go. Thank you. It's actually written over there. No, it's not. Ah, impressive. So yes, this is a neuron. We've got about 86 billion of that in our brain. This is nothing insightful. What's interesting is, despite all the computing power and how sophisticated the artificial neural networks are, just a single neuron can get inputs from hundreds of thousands of other neurons and get an output for another 10,000. And that's just one sort of neuron. In addition to that, it can create a gene expression, create proteins, many things that right now we're not even trying to do in artificial intelligence. So there is a way to go in artificial intelligence, especially when we talk about singularity and other stuff. The brain is a very sophisticated machine, but we're slowly figuring that out. And many times, there's a saying that says the mind is what the brain does. So there's a lot of science into things that we call also emotion. And that's why when I mentioned initially, when we talk about gut feeling is not scientific, it really is eventually science. So after we do a lot of studies, and this is sort of my hypothesis, we may find out that we're merely very sophisticated machines, which may be a bummer. How do you deal with artificial neural network? The first part is the training. That's where the deep comes in. I'm sure most of you know about it, and then you test it with images. It's very good with unstructured data, and that's why we're seeing it a lot of usage in unstructured data. We're seeing it primarily because right now the vision that a machine learning algorithm can have actually surpassed sort of human vision as well. And recently also, DeepMind, a Google acquired company, have developed a much closer resemblance voice to humans through the technology WaveNet, again, leveraging neural networks. And there's been few other areas. One great application that I see of machine learning is primarily on the medical side. So this is just an example of a collaboration between Google and Stanford University. What you have over there is basically an application that scans lesions on your skin. On the left-hand side, it basically tells you it's malignant. You better go get it checked and do something about it. On the right-hand side, it's benign. What's good about this? First, it allows people to diagnose themselves even before they go to any sort of physician or hospital. And secondly, and that's sort of I guess the most important thing, it's not taking the medical doctor away. It's not replacing it. It's just enhancing its cognitive capabilities. How? If you're a medical doctor and you deal with lesions, my father's actually one of them, in their lifetime career span, they see what? 1,000, 10,000 cases? To create that algorithm, we need to go through millions. So there's more experience in a way of the machine on one hand, on that vision, but then you have the physician working together and having another sort of cognitive capability that he didn't have before. So we can minimize the error, the human error as well. Then we can apply machine learnings to cooling centers, salt cucumbers in Japan, translation was mentioned before as well, and project solar panel, finding the right way to get as much solar panel or energy from the sun in different times of day. Have you seen this video, Space Invaders, Atari game, DeepMind algorithm? Should we watch it or no? Yeah. There we go. That's fantastic. So this is basically, there's two parts, I guess, of artificial intelligence. There's narrow artificial intelligence, which is there to kind of solve a specific business problem or an issue. Have I done something wrong? Okay. And then there's general artificial intelligence, which basically tries to mimic us. We have general artificial intelligence. We could talk right now, and we could go somewhere else and navigate and do everything using the same sort of algorithm or different algorithm in the same brain. Machines are not capable of doing that. What DeepMind is trying to do is basically create an algorithm with general artificial intelligence, but with games. So the same algorithm would get inputs from different games, not just Space Invaders, and find out how they can maximize the score. In some cases, it worked better than some cases didn't, but let's see how it did with Space Invaders, since you asked. Oh, video doesn't work. Sorry, guys, I shouldn't have asked. I don't know why. Let's try again. You think so? No, it's embedded. It should be. No. Sorry, but it is available online. So I would recommend that. And in a way, artificial intelligence, I guess, started with games. This is Garry Kasparov with his famous loss. Then we had IBM Watson with Jeopardy, and just recently we had the game of Go. And there was one interesting part of the game of Go which I wanted to highlight. There is a video as well, but it will probably not play. We'll try anyway. And that was Move 37. The games were live streamed all over the world. We had commentators and professionals talking about the different moves because not everybody knows the game of Go. And one of those moves was completely untraditional by the artificial intelligent machine. It was so surprising that they thought it was a mistake. But actually that move that enabled the algorithm to beat Lee Sedol, the champion. Which leads us to maybe think about something we can either define as machine creativity, right? No human has ever done that move before in that sort of context. Or again, in the machines enhancing our cognitive capabilities, seeing a pattern on data. So not reinforced learning, seeing a pattern in data that before that we didn't know existed. So there's definitely other uses on it, again, medical and other areas that some information may elude us as well. Cars is definitely a great industry for machine learning. This is how, I guess, the technology works on a motorway. Primarily 3 technologies over there: radar, LiDAR, and high-definition cameras. Look how complex things are when you move into an urban environment. And that's why it's tricky. Things going on all around you, but the machine knows everything that's happening. And this is, again, also supposed to be a video, again, using the machine learning algorithm, different algorithms to minimize the error rate and understand what's happening in front of you. In this case, the cyclist shows that they want to turn, and the camera gets that, and the car slows down, and so on. We had the same issue with a police officer telling the car to stop. Machine or the vision understands that, stopping and telling it to go, and the car goes. There was also another interesting thing that happened to them, but again, you need to see the video. I can't really say anything about that beside that. People perspective, it's important. More urbanized, more social, and when we come to the workplace, things are different. People require much more flexibility. The hours of 9 to 5 is not as important. But all that is hitting organization, and eventually organizations are not currently, as far as I'm concerned, giving managers the support they need in order to deal with that. That's where a lot of tension happens. That's why a culture is important, and that's why managers today need to live with a lot more uncertainty than they had to in the past. And living in uncertainty means letting go of control, and that's something that nobody likes to do. And obviously, gig economy is a big part of that as well. Business model of change, Airbnb and Uber are just 2 examples, and marketabilization. So the market is paying premium for technology companies. Look what happened 2015 to 2016. 2015, Amazon wasn't even there. Amazon is everywhere today. It's pretty amazing, and 2017 is even more. So all these issues, as I mentioned, are coming to the workplace, to the managers. And I know this is a data science conference, so you guys would appreciate that. In some conferences, I need to explain to people why I have Star Wars elements in a presentation. But when I deal with primarily, I guess, geeks in this case, including myself, I don't need to give that explanation. So there's a great disturbance in the force, Obi-Wan would say, and let's see how Yoda tells us to deal with it. And dealing with it is dealing with sort of new problems, but also understanding that there are old problems to resolve as well. And there's multiple things that we need to get right. It's never just one thing that you have in isolation. So one thing is Agile. Some of you, I guess, have worked with Agile and software development, but it works just as well as a management methodology as well. That's something that we've implemented back at Skype in the days. It helps to put our energy on solving actually the problem instead of planning to solve it. We had some issues with consultants, all that. Sometimes they like to just talk about it instead of execute. And it also hits managers as well, because we need to tame our need, our natural need for unachievable certainty. We can't have that. Nobody predicts the future. And obviously there are things like dog fooding, which is very useful to have. From a lean perspective, less is more. Sorry, this is my phone telling me I should stop. Today, less has never been more than more, if you know what I mean. Anybody heard about the 2-pizza rule? So that's Jeff Bezos saying, if you ever need more than 2 pizzas to feed a team, that team is too big. And that's true, right? It's hard to create innovative products, services, projects, initiative in a consensus sort of environment, going exactly through the rules of the organization and through the different milestones. Almost impossible. Change needs to be organic. If you try to force something that doesn't feel right or isn't organic, it will go away very soon, the turn you hand you back. And that's where culture comes in. To illustrate culture, I know we're out of time, I have this thing. Anybody know what this is? The Norse attack map. So a live cyber attack map shows you the origin and the target and the type of attack. Again, similar to sort of Star Wars. And you could ask yourself, why is this guy showing me a cyber attack map when he talks about culture? And the reason is this, right? In many cases, it's disgruntled employees, leaving the back door open, that's causing a lot of these cyber attacks. Again, there are bad people out there. There will always be bad people out there, but let's not leave the door open. This also begs the question is you can invest a lot of technology, but if you stop investing in your people, you're not going to get the benefit of technology. And that's where sort of the balance comes in. Teams, I always consider the team to be the basic unit of the organization, not the individual. Unfortunately, most organizations today work differently. Performance reviews and other elements in corporations are still very much individual. They're trying to change that. It's not an easy thing. And I think recently, just a week or two ago, they published a letter that Elon Musk wrote to the entire company. I don't know if it was SpaceX or Tesla. I think it was Tesla. And that deals with a lot of those, again, very natural behaviors, negative behaviors that sometimes we see in corporations, anything from sort of a command and control, chain of command discussion, moving through the managers, and all this takes time. These are considered sort of soft skills, but they need to be really actively thought. So dealing with data, taking care of the technology, of the data, of the telemetry, not enough. These issues always need to be resolved and viewed. So eventually I come to the finalization. Everything is a balance. I think that's the key thing for me, especially in the digital economy. Balance, I guess, between art and science. You can call it what you will like as long as it makes sense to you. Between, having a massive revolutionary product, but bringing it in evolutionary steps to the market, potentially. Radical view on how the organization should be structured, to a practical view, having a conviction and knowledge that you're right, or having strong opinions but having them loosely held. Doing, thinking, cognitive, and emotion, and as the late Peter Drucker said, is a lot of these questions that are coming up are eventually human questions that we need to resolve. Technology has brought this, triggered to us a lot of questions that it's up to us to answer, not the machines. And finally, I think Gary Kasparov mentioned the human plus machine will always beat a super machine. I know when they talk about singularity, when they talk about artificial intelligence, sometimes they use the robot from Terminator. But even if you go back to that movie, who won in the end, right? It was the human and the machine that beat the super machine. So that maybe tells us something. And with that optimistic view, I'm done. Thank you very much.
Nice to have the optimistic view. So, questions? Or is everybody itching to get coffee? There must be a question. Yeah.
Thanks, great talk. There's a presumption that AI is going to be based on human intelligence. Do you think we're missing the potential to have a more generalized intelligence that's not necessarily neural net based, doesn't replicate the same behaviors that humans evidence?
It's a good question because there are inefficiencies in how the brain operates. But I think before we can change those inefficiencies, we need to at least be on par with the complexities that the brain deals with in order for us to make sort of those decisions. So I think, and even the artificial neural networks are not nearly as close to the complexity that the different circuits that we have in the brain and our understanding of them. So I think there's a way to go, but I think the way to get there and even to improve our cognitive capabilities goes sort of through the brain. And I think we will see the fields of biology and computing coming together. And there was actually a talk recently about people in vegetative states. And the discussion was whether they are conscious and aware or not. And through functional MRI, which you can see the activities of the brain and understand how these activities correlate to different elements, you could actually ask two questions. One of them, imagine a tennis ball or playing tennis, and that would light up certain parts of your brain. And you could tell the patients that means yes. So when you want to say yes, imagine playing tennis. When you want to say no, imagine walking around in the room, and that would light up different parts. And when you go through those scans, you could actually communicate with that individual. So that's a massive, massive breakthrough. And I think there are more of those breakthroughs to come. And eventually, I think we'll try to connect it into sort of the computing world. That's my view.
Do you think technological unemployment is a big issue, or do you agree with your chairman?
Do I
think that technological unemployment is a big issue, or do you agree with your chairman, Eric Schmidt?
First of all, I agree with my chairman. Let's start with that. And no, I didn't hear about that. But what do you mean by technological unemployment?
The idea that within a generation, certainly two, that most humans won't be able to do jobs, still work, but won't be able to do jobs because machines will do pretty much everything that we can do cheaper, better, and faster.
Well, I currently at least don't think that way. That's why I've ended with sort of the positive view. So I think there are still going to be stuff that machines are very good at, and there's going to be different things that humans are going to be good at. And no matter how much time would go, I think our human capabilities of care, of creativity, I don't see it being surpassed by a machine or not anytime yet. So I think the economy and everything should change, but I think the changes are for the better. It depends. I mean, what will happen 30, 40 years from now? I don't know, but I try to get an optimistic view. So right now I see the machines coming in as a positive thing. I think if we can all stop driving and have machines drive everyone, I think we'll be a better place. I mean, I know some people like to drive. I personally don't, but that's already, I think, to me is a great ideal.
Final question.
Thanks, Dvir. Good talk. I'm less concerned about killer cyborgs and even unemployment. What bothers me is that I see that there are bias that exists in every facet of our life and certainly business. And actually, I see that some ML only exists to reinforce those bias. What's your belief on kind of certainly corporates misusing ML and reinforcing bias. So whether that's deciding to give people credit based on ethnicity or all of these issues.
No, you're right. I mean, whoever sort of writes sort of the algorithm, whatever sort of data that comes in, that's what eventually the AI and machine learning would do. I mean, there was the experiment that I guess Microsoft did in the days with their chatbot, and that didn't really go down well. Who knows about it? I'm not going to mention anything else. So it is an issue. But there's one thing that the speaker before me said, I think, or was it Yuval Harari? I don't know. Technology is the basis of sort of human progress, and it's been this case throughout the years. I think what we're seeing now is the frequency of technology and innovation is increasing. That can't stop, and that shouldn't stop. But I do agree that any sort of good thing, unfortunately, sometimes come with a residual sort of bad, and we need to find out how to kind of take the good and minimizing the bad. There's always going to be people who are trying to abuse that. That's a separate issue. But in this case, you're right. And I don't think anyone has got an answer to that. That's why I think Google, as well with a lot of other companies, are trying to democratize AI, to make it easily to use, almost as easy as now cloud is easy to use. So more people could get access to that, understand that it's not magical issue, it's a lot of mathematical models. But if we make it simple for people to use and understand, hopefully we could reduce some of that bias. But I agree, it's an issue.